So Alex has a question. And Alex's question that I looked on his notes, because he wrote it down on his little sidebar thing. The one thing is, remember, ladies and gentlemen, when we were looking at equations, right, we wanted to find the value, or we wanted to find the values that made our equation true, right? So remember, when I first showed you guys how to graph quadratics, remember it's a parabola, right? The shape of the graph is a parabola. It either opens up or it opens down. So I'm going to tell you 3 different types of a graph, all right? And we're going to look at each one of these separately and kind of see if we can understand them. So there's 3 different types of solutions you guys are going to have of a parabola or a quadratic function. So when graphing them, there's 3 different types you can have. All right? Now remember, it's going to be a U-shaped graph, right? All right. So the first type is we could have one solution. Now remember, ladies and gentlemen, we're talking about functions, right? So we have an x and an f of x. Now, what is the value of f of x at the x-axis? What's the value of f of x at this x-axis? Okay, well, let's see here. Yeah, it's 0. What's the value of f of x here? It's at 2. Here's at 1. Here's at 0. So if I say there's one solution, that means there's one number that is going to make my function true, or I'm sorry, my equation true. All right? So that would be an example of one solution. There's also the example of, I'm going to more explain it here in just a second. I'm sorry? I'm going to explain all that in a second. Then there's another type of parabola. So remember when I said when we're talking about when I said find the solutions, the roots, the zeros, right? We're going to find the values of x. So there's one where you could have one solution that's going to make it true. Here is an example of a graph that shows 2 solutions. So these are just examples, Emma, of just me graphing parabolas that are going to have these type of solutions. So here would be an example of 2 solutions. Remember when we talked about solution in the last video? A solution is what? The values of x that make your equation equal true, right? But remember, yeah, Ken, what was your question? Right. So here is an example of when you have more than one solution. I'm going to get to the algebra in a second. All I want you guys to do is just geometrically kind of look at these and understand. Here's an example where it only crosses the x-axis once. So at f of x equals 0, there's only one number when it equals 0. Here, at f of x equals 0, the parabola, there's 2 values. And then here is an example when f of x equals 0, there's no values. There's no solutions. Because remember, ladies and gentlemen, we're talking about equations. Right? We're talking about when is our function equal to 0. Well, it's equal to 0 at here. Here is when f of x equal to 0. Right? F of x equal to 0 on our x-axis. So we're trying to find out when is our f of x equal to 0. What are the values of x when it's equal to 0? Well, here is an example of one solution. Here is an example of 2 solutions. And here's an example of no solutions. So let me go and show you algebraically. Let's make up some problems that would represent these. Does that probably help you out? All right. Well, let's say I have the graph f of x. Let's say I have the function f of x equals x minus 5, plus 5 squared. Let's do f of x equals x squared plus 9. And let's do f of x equals x squared, minus 9. There you go. And let's do x of x plus 1. OK, so let's say I have these 3 functions. All right, now, give or take, I'm kind of making these up as far as my notes. These aren't going to exactly go with their graphs. All right, but let's pretend, let's say I wanted to solve them, right? We're talking about finding the solutions. right? Remember I told you last video we said find the solution, or first find the zeros. That means when f of x equals 0. So I have x plus 5 squared. Now, we need to solve for this, Destin. We need to solve for x, right? We need to find the values of x that are going to make this true. So does anybody know what inverse property I'm going to want to use first for this? Yes? Yeah, you got to get rid of the square root first, right? Use the reverse order of operations. So I square root on both sides. The square root of 0 is 0. So 0 equals x plus 5. Now, to find the value of x that makes this true, I subtract 5 on both sides, and I could say x equals negative 5. All right? So therefore, is there only one answer? Yeah.
Oh, x.
X, the value of x. 1, 2, 3, 4, 5. X equals negative 5. That is the only solution that makes this function is true when f of x equals 0. That's the only value that makes this equation true. I'm sorry? We did. We set it equal to 0, and then we solved for x. We did what you said. We set it equal to 0, and then we solved, and we got x equals negative 5. Remember we talked about zeros and roots? Remember? We talked about, that was the last video we talked about. When we're talking about a quadratic function, now we're talking about a quadratic equation. The quadratic equation, we set it equal to a value of 0. And remember, the roots, you got to look back at your definitions. The roots and the zeros, that's what we're finding right now, are the roots and the zeros. What are the values that make it true when it's equal to 0? When f of x is equal to 0. And what do you guys notice graphically, when it's equal to 0, what exactly is that point? It's called the what? Intercept. X-intercept, right? So you notice that the roots and the solutions and the zeros are your x-intercepts of the graph. So let's look at it over here and see if you guys can have this. Take a look at this one. So for this one, next thing I do is set it equal to 0. Yes? Yep. With what? Distributive property with? No, you can't distribute the squared to both of those. Yeah, if they're multiplied, you could, but the addition, you can't distribute that. So now, what's the first step I'm going to do here? Yes? Before you unsquare it, we got to follow our reverse order of operations. We have to undo what first before we can unsquare it? Right, you got to make sure we add 9 to the other side first, then we can undo the squaring. So I add 9 to the other side, so I get 9 equals x squared. And now I undo the squaring. So x equals what values? 3. What about negative 3? And negative 3, right? Because negative 3 times negative 3 equals 9. And 3 times 3 equals 9. So what we say is plus or minus 3. So do we have now 2 solutions for this problem? Yeah, we do, right? So we have 2 solutions. Now, let's look at one more when we have no solutions. All right? So if I have, again, I set that equal to 0, right? Because I want to find the zeros, or now when I have it as an equation, I'm going to find the roots. Same thing. I subtract the 1 to the other side, so I get negative 1 equals x squared. Take the square root. So what 2 numbers multiply to give you a negative 1 that are exactly the same? It's impossible, right? So here, what we say is there's no real roots. And you can see, does it cross the x-axis at all? Is there any values that make it true when it crosses at f of x equals 0? No. So there's a visual and an algebraic way for you guys to see that. OK? Yes?
Why don't you use plus or minus for one solution? What makes it different in 2 solutions?
Because here I'm taking the square root of 0. There is no plus or minus when you take the square root of 0. Does that make a little difference?
Yeah.
Yes. All of order of operations. Remember, yeah, it's, yes, reverse order of operations. Any other questions? That's a good question, though, to write down. Could you write that one down, please? That's a good one.